Okay, here we go. We're pricing a swaption. Brad Williams, Frugal Finance. This is going to be a lot of number crunching like all option related pricing. It's just a matter of plug and chug. We're using Black model. It's pretty straightforward. It's just a matter of recognizing the equation and understanding the logic, and then where is the information coming from. With that being said, Table 2213 presents term structure information that we will use for several swaption examples. Consider the yield curve environment from the point of view of time zero. A forward swap begins in 4 years and has semi-annual payments, a tenure of 3 years, and a notional principal of $75 million. The SFR for this forward swap is as follows. SFR 14 down here, summation time 9, FRA time 0, divide this 14, 9Z. What does this mean? Treating the numerator and denominator separately for convenience, we have the following. Numerator is going to equal 0.369898 right here, our forward rate. Divide that by our zero rate. Plus, and we're going to go from 9 to 14. This is our numerator. Got that? Can equal 0.163706. Then our denominator, we're going to take the 137,685. 14304, we're going to do this exact same thing. We're going to come up with 3.94. Our SFR is going to equal 0.163 divided by 3.94 equals 0.4. On a semi-annual basis, then 4.14 for an annual. So we have an SFR of 0.082954. So we have this number here, and then I just follow these exact same steps. Consider now a payer and receiver swaption on this forward swap from the point of view of time zero. The payer swaption has a strike rate of 8% in annual terms, and the receiver swaption has a strike rate of 9%. The standard deviation of the forward swap rate is 0.11. First, for the payer swaption, DISA 1 and DISA 2 terms are as follows. Now keep in mind, here's the equation worked out. So we're going to have 0.0829, and that's going to be a log normal 0.82954. So we're going to take the SFR 8294 if you want to just get really particular about it. Looks like 8.9254, and we're going to divide that by our strike rate plus 0.05 times 0.112, which is going to be time, t minus t. We have 0.05 times 11.11, looks like power 2 times 4, because our swap rate is 11 here. 2 periods because semi-annual, times 4 years, divided by 0.11 times the square root of 4 to come up with DISA 1. DISA 2 is going to be the standard deviation, and then we know this time is going to be 11. 27486, the number above, minus 11 times 2. Then the cumulative normal values are going to be our normal distribution of 24786. And then we're going to take norm 054816. Then we're going to use the formula here to come up with ND gives the expected value probability adjustment of paying out the strike price is 3.94, and the payer swaption in a P is priced at 182,149. The cost of the payer, the cost of the payer swaption is 1.2 million. The cost of swaption is often expressed in basis points of the notional principal. The swaption cost is 171.89 basis points. 1.2 million divided by 75 million times 1,000 equals 171. Are you willing to pay 1.2 million for this swaption? We now turn to the receiver swaption, which has its own DISA 1 and DISA 2 terms. It's pretty straightforward. Keep in mind what we're looking at here in terms of numbers. We're still looking at this 0.82954 number, which is divided by 9. Excuse the rounding errors here. Here's our SFR up above. And it's this number right here, 8296. There's a rounding issue here. It's way off. This makes no sense. 3946, 414, C9. Okay, I made a modest typo error. Right here, I entered 136828 right here. And that threw this entire number off significantly. And this number here doesn't seem right. 8.2954, and I have 8.29608. In this example, you can see the basis points. We're off 8.2954, and I have 8.29608. That's big. You cannot make these typos in this application. We have 1.48, and then we're taking C14 times 2, so that something's screwy here. 8.2954 against 89608. I'm just going to go with this, but you can see the typos. I went out, what, 1, 2, 3, 4, 5. I went out 6 decimals. I mean, that's huge. Well, I'm not going to worry about it, but when you're inputting your data, type it in correctly, because it will screw this entire pricing model up a bit. So my numbers probably, they'll be close. Just be extremely careful when you enter your data. So that being said, we're looking at this receiver swaption. We're going to see the numbers are going to be off a little bit. Sorry about that. So it could be 8295, because these are hard-coded, and that could pose all kinds of problems here. 82, this would be, see right here, our swaption with 8.29608, and I used 8.2954. That's going to throw things off a little bit, but we'll just go with it. At least I pointed it out. Here, we're using this 8.2954 divided by 0.9, and we just follow the same steps. We're just changing the numbers around a little bit because now it's the receiver swaption. And we're going to find DISA 1, DISA 2. Then we're going to use the normal distribution to find the remaining information. And here, you're going to see the cost of the pair swaption is 1.71 million, or 229 basis points. That's a pair swaption. They're not cheap. Would you, as a CFO or treasurer or VP of finance or whatever title it is, would you take this bet for a rise or drop in interest rates? Comment. Let me know. Brad Williams, Frugal Finance. Thanks for watching.